Equations from previous parts of the book, and we went through and derived. You don't know how to derive this, so I'm not going to go back through that again. It's in your book. But this is what we end up with. We got this quantity, delta G. That's abbreviation for Gibbs free energy. What is free energy? It's the change in the entropy of the universe times negative T. Delta H, standard, this little circle, that means measured under standard conditions. And because quantities change, but we can't list the quantities at all the different temperatures, that would be a massive amount of information. So what we normally do is just take the standard, even if it's not at 298. So these are measured at 298, but even if you have a problem where the temperature's not 298, you can still use these standard measurements. So this is basically the second law, just written in a different way. And we also talked about we can be given these delta H, delta S, or we can calculate them using some of these equations that we talked about earlier. Next thing you want to know, so delta G reads free energy change. If this change is negative, that means the process is thermodynamically favorable. If you think back to what we said about the second law, irreversible spontaneous processes lead to an increase in the entropy of the universe, and we're multiplying the entropy change of the universe by negative T, which makes it negative. So now delta G, negative values are favorable, spontaneous, and positive values are unfavorable, non-spontaneous. And if delta G is 0, that means the system's at equilibrium. So you can describe the system in three different positions. Forward process is spontaneous, reverse process is spontaneous, or it's at equilibrium. By that. So this kind of gives us, before it was, well, if it's exothermic, it's probably, if it increases entropy, it's probably, now we can say, if delta G is negative, it's definitely favorable under those conditions. This is a chart that kind of goes through the signs for this equation and talks about favorable and unfavorable. So here's your, you got four scenarios you have to learn. You got a negative and a positive. These are both favorable, so this is favorable at all temperatures. That means you got a delta H minus T delta S. So both these terms are negative, then delta G, no matter what numbers you put in there, is negative. The opposite of that is you have plus and a minus. That's unfavorable, unfavorable. When you put in a negative delta S there, it's going to be a positive term. So you have two positive terms. That means delta G is positive under all conditions, so it's always unfavorable or non-spontaneous. Then you have your two temperature-dependent situations. That's where both signs are the same for delta H and delta S. If they're both negative, that means that this term is going to be positive, so you got a negative and a positive term. This term is going to determine the sign at low temperatures. This will determine the sign at high temperatures. So this will be favorable at low